A unit circle is a circle with a radius of 1. Okay, so the radius of this circle is 1, and the center of the circle is the point 0, 0, the origin. Okay, and what this problem is asking you is basically to find all the values that lie on this circle. Okay, but in addition, it asks you to find points A, D, F, and B as well. So when you're looking at this, here's the information that they provide for you. Okay, so here's points A and C. Okay. And B is the origin. So that one you should be able to find. The other thing they tell you is they give you the angle measure. So the central angle here is from C through A, or C through B, then through A. In this first one is given as 30 degrees. So what type of a triangle are we dealing with here? It's a 30, 60, 90 right triangle. It's one of those special triangles. Well, they told you that the radius is 1. And so based on this, the information that we can derive is, if the hypotenuse is 1, what's the length of the side opposite 30 degrees going to be? Half of that, or 1/2. And then if you know the side opposite 30 degrees is 1/2, what does that mean the side opposite the 60-degree angle is going to be? 1/2 times root 3. So root 3 over 2 is this length. Well, this allows you to find the coordinates for A. It has an x-coordinate of root 3 over 2 and a y-coordinate of 0. Point C has an x-coordinate of root 3 over 2 and a y-coordinate of 1/2. Again, just looking at those distances on the right triangle. Does everybody see that? So now what you can do is you can look for the next triangle. The next triangle is formed at this 45-degree angle. So this is point D and point E now. So if you know the hypotenuse is still 1, the radius of the circle, what do you do if you're given the hypotenuse to find each leg of an isosceles right triangle, a 45, 45, 90? You take the given side, the hypotenuse, and you divide by 2 and multiply by root 2. So 1/2 times root 2 gives you this length. Root 2 over 2, 1/2 times root 2 divided by 2 is this length as well. So once again, you can find the coordinates. For point E, the x-coordinate is root 2 over 2, the y-coordinate root 2 over 2, and then point D down here has an x-coordinate, root 2 over 2, and a y-coordinate of 0. And you go to the very last angle. The last angle is 60 degrees, so you wind up with the same 30, 60, 90, only this time the measures are flip-flopped. So this side opposite 30 degrees is 1/2, the other side is 1/2 times root 3. So the x-coordinate of 1/2, y-coordinate root 3 over 2 would be your coordinates for point G. And then F, again, would have just the coordinate of 1/2, 0. And now, the useful pieces of this problem are the pieces that lie on the circle. Okay, I really don't care too much about these down here. Okay, the whole gist of this was, can you derive these points? Because on a unit circle, the x-coordinate of any point that lies on this unit circle corresponds directly with the cosine of the angle, the central angle formed when it intersects that point. So here, this angle of 30 degrees has a cosine of root 3 over 2. The sine is the y-coordinate on a unit circle. So the sine of 30 degrees, if you type that into your calculator, gives you 1/2. For a 45-degree angle, the cosine of 45 degrees is root 2 over 2. The sine of 45 degrees is root 2 over 2. And for a 60-degree angle, the cosine is 1/2. The sine is root 3 over 2.